Let's talk about the role of control statements in a programming language. Control statements, such as if and while, are different from functions in that they control which parts of the code get executed and how many times. But maybe we could have that same control just using functions. Well, let's explore. Let's try to write a function that does the same thing as an if statement. Here's a particular format of an if statement, and the execution rule for conditional statements is each clause is considered in order. Then, what we do when we consider a clause is to evaluate the header's expression if it's there, and if it's a true value, or we're an else, then we execute the suite and skip the rest of the clauses. So here's the if clause and the else clause. If this is true, then we execute this and skip this. If this is false, then we don't execute this, find out that we're in the else condition, and execute this. So the if header expression controls whether the if suite or the else suite is executed, but we always pick one or the other, and we never do both. If we were to write a function, let's say there was an if function that took a header expression, an if suite, and an else suite, couldn't we just write our code like this? Well, first of all, this doesn't exist in Python, but I think we could try to implement something like this. And what it would do is if this were true, it would return whatever the if suite value is, and if it were false, then it would return whatever the else suite value is. So how might we implement that? Well, let's just implement it using the conditional statement that we already discussed. If C is true, we return the T value, otherwise return the F value, where we pass C, T, and F in. Sounds great. Now, instead of having to write ifs and colons and remember what to indent, we could just use this if function wherever we want and write all our code that way. But there's a problem. The problem is that the evaluation rule for call expressions is quite different than for conditional statements. This call expression is evaluated by evaluating the operator and operand sub-expressions, then applying the function, if underscore, to the arguments that are the values of the operands. In what case might we see a difference between using an if statement and using an if call expression? Well, let me show you. Here's my if function. We're not going to use it at first. We're just going to focus on writing a function that computes the real square root of x, where x can be a negative number or a positive number. The real part of the square root of x only is non-zero if x is positive. And for positive x, the built-in square root function will give us the square root. For a negative x, like what's the real square root of negative 4? Well, the square root of negative 4 is 2i. And I is imaginary number, 2 is the imaginary part, and the real part is 0. So we write a simple function. If x is greater than or equal to 0, return the square root of x. Otherwise, we have a negative number. We're not going to call square root on x at all. Instead, we're just going to say that the real part is 0 because the whole square root is imaginary. So let's run this. And we're letting the built-in square root function tell us that the square root of 16 is 4. But the built-in function would tell us that the square root of negative 16 is an error. We don't want that behavior. Instead, we want to know that for positive numbers, the real component of the square root is 4, and for negative numbers, it's 0, because the whole square root is imaginary. And this implementation works just fine, because in the case when x is 0, it computes the square root, and the other case, it just skips over that and returns 0. What if instead we took the components of this if statement and converted it to a call to our if function? If x is greater than or equal to 0, then we want to take the square root of x. Otherwise, we want to return 0. we could return the result of this and replace this conditional statement with a call. What's going to happen here is that it's going to call if on these three things, which come in as C, T, and F. If C, then, I need to return T. Otherwise, I return F. And now I have a very convenient implementation of real square root that all fits on one line. Let's watch it work. It's still the case that the built-in square root works only on positive numbers, but my function, real square root, gives me the 4 and the error. What happened? Well, when we replaced the conditional statement with a call expression, we had a different evaluation rule. For evaluating this, we figure out what function we're going to call and all three arguments that we're calling it on before we ever execute the body. And so we found out that x was not greater than 0. We attempted to compute the square root, and before we ever got to the 0 or got to this, we reached an error because the square root of a negative number was taken. Call expressions don't allow you to skip evaluating parts of the call expression. Instead, all the parts are always evaluated before the function is called. And that's different from control statements, which actually pick which parts of the statement are executed and which parts are skipped. And that's why they exist in a programming language instead of just having functions.